Hello everyone in CSC-121 Graphical Python Programming. We're in Module 1 and the purpose of this video is to get you up to speed on object-oriented programming. So, at this particular moment in time, most of you have not taken the CSC-120 class because this semester would be the first time that class is offered. I'm talking to you in the fall of 2021. But folks that watch this video perhaps in semesters after this one, you may have had an opportunity to take CSC 120 that replaced Programming and Logic CIS 115. So I'm going to mention some of the material and I've made it available to you so that you can get a little bit better background into objects before you dive into the material in this class, CSC 121 Graphical Python Programming. So let me share my desktop here. And let me double check to make sure that that we got it switched, and we did. That was a little screenshot of OBS, Open Broadcasting System. Just a great program for making videos, streaming video, capturing things, and it's all free, open source. So you can see my desktop here, and this is a screenshot that I did to kind of help you understand the relationship between a class and an object. But before I talk much about this, let me show you that material that I was just mentioning. So here I am in Module 1 of CSC 121 Graphical Python Programming, and these two lectures right here I actually copied in to the class from the CSC 120 class, because I know some of you that are taking this CSC 121 class will not ever take CSC 120. You got credit for CIS 115. So these lectures go into a lot of detail about how objects work in Python, and they explain a whole lot more stuff than what you really need to know to do graphical programming in Python. And this class that we're in right now, CSC 121, has been created for about 3 years now. And so these lectures were made 3 years after the homework questions and the exam questions were made for your CSC 121 class. The point I'm trying to make to you is you may find the answers to some homework questions or some exam questions in these lectures, but I did not pull my exam questions from these lectures, although they may give you a much better understanding in depth of why some of the answers to the questions in this class are what they are. So those are two lectures that you can watch. You are not required to watch them. I put them out there simply to help you folks, and hopefully you will get some benefit out of them if you decide to watch them. So here's where we are. This is the video that I'm making right now to get you up to speed on what you need to know in order to do graphical user interfaces, GUIs, with Python. And so let's talk a little bit about the basics in case you don't watch these videos here. We can go through some of the basics of objects and classes. So a class is the pattern or the blueprint that is used to make an object or to make multiple objects. Okay? If you've got this, think of a class as a recipe. If you've got this recipe for chocolate chip cookies, you could bake lots of different batches of chocolate chip cookies, couldn't you? Okay? So when we actually mix those ingredients and we bake it, then we get our chocolate chip cookies in existence. Well, in Python, when you make something from our class blueprint, you get an object. You get an object. So an object is really taking the pattern from a class file and making something, bringing it into existence. And you can see right here I wrote an instance, also known as an object, is a particular realization of a class. Unlike C++ and Java, Python supports both class objects and instance objects. That means we can set a variable equal to an object. Okay? In fact, everything in Python is an object. Okay? So when we define a class, and if you think about it, DNA, if you've got DNA for a person, then if you had the complete DNA for a person, theoretically you could make a person from that DNA. Okay? So DNA is the pattern that they use to make a person, or a dog, or an animal, or unfortunately a virus. So the class is our pattern or our DNA, and a class has these three things. Okay? It has a name, a class name. It has static attributes. Think of those as data. And it has dynamic behaviors. These are methods that cause some action to happen. Okay? So if you think about a class like this, if we made a class for a person, okay, a person has height, weight, hair color, eye color. Those would all be static attributes of a person. But people can do various things. They can walk, they can jump, they can, do all kinds of different things. Those are actions. So those actions are methods. Okay, that's a name for a behavior of a class, is a method. Okay, so think of a class as a 3-compartment box, okay, or pattern. Okay, when we bring an instance of a class into existence, then we get one that's got a specific name, a specific hair color, eye color, height, weight, so on. Okay, and so you can get to the attributes like height, weight, hair color, so on, using the dot operator. So we can get to those, and those are basically just variables inside the class. Okay, they're just variables inside the class. Okay, so we use a dot operator to get to them. That's also known when you put a dot, when you use an object name and a dot, that's called dereferencing, and it lets you get to either a variable or attribute of the object, or it lets you call a method of the object. Okay, so, and here's kind of the relationship. You could have all these different classes that are all these different objects that are brought into existence. Now this line's kind of important right here, okay? Where it says instance name, that would be the name of the class, not class, that would be the name of the object. That would be the name of the object that we brought into existence. So this would be the name of the object. Over here, this is the name of the class. And you notice they've got the parentheses on the end of it, and they've got some arguments inside there. So this is the way you actually bring an instance of a class into existence, and that is called an object. Okay? So, and you can see an object-oriented program consists of many well-encapsulated objects that are potentially sending messages back and forth between each other. Okay? So, that's kind of the 10,000-foot view of the way this object-oriented stuff works. Now let's go look at some of the W3Schools material. And these videos up here from CSC-120 also look at a little bit of the W3Schools material as well. So you may get a little bit of duplication if you watch these two videos up here and then see this, what I'm talking about right now. So let's pop into that. And you can see that this is probably our simplest example of a class definition right here. This is the pattern that we would use to define a class. Now, just like if we were creating a function in Python, okay, you can create a function, but if you never call that function, it never actually does anything, right? So right here what we have is we have a pattern to make something, okay? But we have never actually created anything from this pattern. So this is just a pattern that hasn't been used to make anything yet. What it is doing is it's defining an attribute. Remember I told you they were variables, okay? It's defining an attribute named X that every instance, every time we create something from this pattern, it's going to get a variable named X, okay? So right here's where we're actually using that, okay? So we can take this and we can put it into Tawny and actually try this out so you can see what happens. And so let me pop into Tawny here. There was a little Hello World program that I was doing. Okay, so let's take our class definition right here, the pattern, and I'll paste that code into Tawny. Okay, so there it is, and I'm gonna just go ahead and check my indentation. I hit tab. You know how when you paste things from the web into Tawny, you may not get your indentation exactly the way Python wants it. So then I'm going to take this code here and put that into Tawny as well, and I'll there's no indentation going on here. Okay, so let's talk about what's happening here in the W3Schools stuff. So this is a pattern for a class. Okay, here's where we create an object named P1. Okay, and here's where we're actually getting to that private, or excuse me, not private, that public attribute of that class. Okay, so let's do this. Let's run this code and let you see what happens when I run it. Okay, did you see the 5 that came out down below. Okay. Now, just to prove to you that we could have more than one of these things going on, we can do that with the next little example, because the next little example is showing you a little bit about a constructor. Okay? The constructor method in Python, now you don't have to define a constructor method for a class, but if you want one, this is the way you do it. Okay? So I'm going to take this, and while they spun off, they did my class, and then they created an object named P1 from it, and then they jumped into something else here called a person. I'm going to go ahead and continue on with the thought process that we had going with the first example rather than jumping around. So I'm going to take what we had here, and I'm going to go ahead and put a constructor in here. Now you'll notice the constructor method has this special name called underscore underscore init underscore underscore. Every method of a class has to get a reference to self. Now I guarantee you this is going to mess you up at some point, because you're going to create a method for your class and you're going to forget to pass self to it, and you're going to start getting messages about, oh, that your wrong number of parameters or something, or wrong number of arguments or whatever. So just remember, the first thing that gets passed is always self. Now if we want to pass something to this, we could actually do this. We could say a comma, and num is what I'll just call this parameter. Okay, so now I can do this, self dot x equals num. Okay, now what did that just do? That's going to let me, when I create my instance of a class, it's going to let me pass something to it. So I'm going to pass a 7 to it now. Okay, so now what's going to happen when we run this code is this 7 is coming in to my constructor right there in num. Okay, I'm setting self.x equal to num, so that's going to give me a public x property that I can then get to. So let's run this now. Let me clear this out and let me run it. You can see I get 7 out now. Now why did I go to all that trouble? Because I wanted to show you something. P2 equals my class 20. Okay, so now I have a P1 object. The P1 object's x property is, okay, and I have a P2 object as well. I created 2 of them, didn't I? Using the same pattern, but they have different data. Each one has different data. So now watch what happens when I run this. Okay, the P1 object's x property is 7. The P2 object's x property is 20. So that's just showing you that we brought these 2 things into existence, and they have different data. They have different data inside them. Remember right here when we were talking about this? Okay, the name is P1 and P2, right? The static attributes, okay, the static attributes, that is this X. Okay? We haven't written any behaviors for it. We haven't written any behaviors for this class yet. If we were going to write a behavior for it, we could do that. We could have it print, have it do an x squared or something, and then that would be a behavior, a method. So we're getting into two different names here that you haven't probably not heard before. The variables that are part of that class are called properties. The behaviors are called methods. Now we implement a behavior like this. Okay? Def is going to create a behavior, and I could call this behavior, I don't know, print square. Okay? Now remember, when you're every method of a class has to get a reference to self. Okay? So even if we're not doing anything but printing something out in here, we've still got to get a reference to self. Okay? Now here I could do something like this. Print the square of x is self.x. Now you notice, in order to get to that x inside my class, I have to say self.x. Okay? So now this is a method or a behavior. Okay? It behaves by printing the square of x. Now to actually get this to print out the square, we would need to do, isn't that the way you do a square in Python? Let's go ahead and call that method here in a second. Okay, so let's call the print p1 dot print square, like that. Let's see if it works. So we're saying, hey, object P1, go out and print the square. Okay? So here goes. Okay? You see what it says? The square of x is 49. The square of x is 49. 7 squared is 49. Okay? So it did what it was supposed to do. It did what it was supposed to do. And of course, our P2 method also has a print square method as well. So that's a little bit of an example that, had some continuity to it. We started out with just the my class, and then we wrote this constructor, and then we wrote this method, and I showed you that you could have more than one. Okay? Now here's some code that they did in W3Schools, and you can click that button and actually try this code out. But I'm going to walk you through what it did. Okay? You should recognize this as the constructor method. So right here's where that constructor gets run. The constructor gets run when we create an instance, when we bring an instance of our person class into existence. So this line is called where we instantiated a P1 object. Okay? So remember that every method of a class has to get a reference to self. Now you could call this anything you want, but Python is going to take whatever the first parameter is to every method of your class, and it's going to assume that is a reference to self. Okay? So what's going on in this constructor for our person object? It's taking name parameter and it's stuffing it into self.name. It's taking age and it's stuffing it into self.age. Okay, so here's where we bring the P1 object into existence, or make it come alive, and it gets a .name property that's John. It gets a .age property that's 36, and down here's where they actually just printed those properties out. Okay, so scrolling on down, you can see that here's another example of creating a class. Right here's the class definition. Okay, what I have highlighted in orange is what we call the class definition. This has got a class method defined called myFunction, okay, and it's doing this print that says, hello, my name is, and it's printing self.name. Okay, now notice that in order to see that, in order to cause that method right here to run, you had to put the parentheses on the end of the method name, right? So just like to call a function in Python, you had to put the parentheses on the end of the name of the function to call it. This is actually a method. This is a method of a class. Okay, this is a method of a class. In order to run that method, we have to put the parentheses on the end of it. Okay, so think about this for a second, what we had going on here in Tawny. Okay, this is the way in graphical Python, when we want to show a what you would call a form in Visual Studio. Okay, if you've taken Visual Basic or one of those other languages, C#, okay, and you had a form, okay, well, our forms in graphical Python are actually called dialogues, and dialogue is actually an object, or a class, sorry. A dialogue is a class, and we bring an instance of a dialogue into existence, okay? And you can set various things about it, and each one of those dialogues, or in Microsoft speak, those forms, each one could have its own data associated with it, okay? So this stuff is the heart of what we'll be doing with graphical Python programming. So you need to understand enough about how classes are defined and how objects are instantiated in order to do the graphical Python stuff. Okay, so some of the other things that this object-oriented programming gives us, if you watch those videos up here, you'll know that they give you encapsulation, and we saw a little bit of encapsulation going on here, where each one of these objects had its own data, okay? But some of the other things that this object-oriented programming does for us, it lets us inherit things. So one class can actually inherit from another class. So you don't have to reinvent the wheel, okay? You can actually have a class that inherits all the stuff from another class. So that makes it real convenient to write programs, in the inheritance stuff. And we'll be using that in graphical Python because our dialogues that we create are actually inheriting from the dialogue, and then we're adding the dialogue class, and we're adding things to them. So we don't have to write all the code to make that dialogue, or that form, if you want to call it that, we don't have to write all the code to make that thing happen. All we have to do is inherit one and then add the stuff that we're doing to it. So it makes your programs sometimes a lot shorter. It makes your programs easier to understand. So that's inheritance. The other thing that you get with object-oriented programming is you get polymorphism. Polymorphism. Now the word poly means many. The word morph means changes, right? Changes. Okay. So if you morph into something else, you change into something else. Okay. Polymorphism means many changes. Okay. So we can actually inherit, we could inherit this my class right here, and we could actually in the class that we create that inherits this, we could actually write a different print square function or method, and the one in our class would replace this one. So you could actually, that's called overriding a method. So we could actually override the print square method from the original class and have ours do something different, or have it do more. Okay, so polymorphism and inheritance. Okay, we talked about the dot operator already. Let's talk about this in terms of a turtle for a second. Way back in Module 1 of CIS-115 or CSC-120, we did an import turtle. Okay, that was where we were actually importing the turtle class. When we had our turtle move forward, it was actually a method of our turtle class. We were calling a method that caused that turtle to move forward. Some of the other things that the turtle class had, it had a shape. You could make your turtle be a turtle or a circle or a star or lots of different things. So it had all kinds of different properties that you could set. For the turtle. You had a turtle name. So that's trying to compare what I just did here with this to the turtle stuff that we were doing at the very start of your Python journey here at RCCC. Okay? So let's look at a little bit more here. Now, once you've gone through that material at W3Schools, okay, these are some extra things that you need to know in order to answer the homework questions, okay? We've already talked about this one in this video, okay? The constructor method, okay? There's another special method that you can create for a class, okay? The W3Schools stuff does not talk about a destructor for a class, okay? So down here's a video where it says constructor and destructor walkthrough. This video right here and this code actually shows you a little constructor. It shows you a little destructor. And down here, if you uncomment one of these two, you can actually cause Python to run that destructor. Okay? So there's a video. There are lots of videos in this class. Okay? You've got a video here that talks about required in every program that you write for this class. Every program that you write for this class needs to have a line like this down at the bottom, and then it needs to call whatever. So you'll see this in action, and if you watch this video, you'll understand why. You'll understand why we're doing this. Okay, so there are videos in almost every one of these areas here in Module 1. So that's a little introduction to objects. Again, you can watch these to get a whole lot more, a whole lot more information on objects. Well, good luck in Module 1. Remember that in Module 1, you have Project 1 the first week of our semester. And if you don't get that program written for Module 1 the first week, you won't be able to do the exam the second week of class, because the exam actually imports, the exam has you import the Project 1 that you create in the first week of class. So don't wait. Get in there and do Project 1 right away. And if you need help, then you've got all week to get help with it, rather than waiting till next week. Because if you wait till next week, you'll have the homework, you'll have the exam, which is actually 2 parts. It's got a project for you to do that's part of the exam where you import your Project 1. So we actually inherit your Project 1 in the exam. So if you don't get Project 1 done, your exam project is not going to work for you either. So I'm trying to give you as much notice as you can to get this stuff done. And so good luck with the first week of graphical Python programming. This is not hard stuff. There's just a lot of it. So go through there, follow the checklist, and get started with the object-oriented programming material. Take care.